Picture this, a swirling tapestry of light, stretching across the night sky like a cosmic masterpiece. This is the Andromeda Galaxy, our closest galactic neighbor, a place where over 1 trillion stars dance in perfect harmony, each one a tiny spark in an endless sea of darkness. Tonight, we're going on a journey, not just through space, but through time itself, because the light you see from Andromeda tonight began its journey 2.5 million years ago, long before humans walked the Earth. What secrets does this ancient galaxy hold? What stories could its stars tell if they could speak? As we drift through the mysteries of Andromeda, we'll uncover its hidden wonders, from its colossal black hole to the delicate swirls of its spiral arms. But this isn't just a story about science, it's a story about imagination, about the beauty of the unknown, and about the quiet, awe-inspiring vastness of the universe. So, wherever you are, whatever time it is, let's take a moment to look up, to wonder, and to dream, because tonight, we're not just observers of the cosmos, we're part of it. And as we explore the secrets of Andromeda, let's remember, the universe isn't just out there, it's within us too. Where are you joining us from, and what time is it there? Let us know in the comments, and let's begin this journey together. Now, let's step back in time to uncover how humanity first came to know the Andromeda Galaxy. Long before telescopes, ancient civilizations gazed at the night sky and saw a faint, fuzzy patch of light. To the naked eye, it looked like a small cloud, but this was no ordinary celestial object. Early astronomers, like the Persian scientist Abd al-Rahman al-Sufi in the 10th century, described it as a little cloud in his book of fixed stars. Yet for centuries, its true nature remained a mystery. Was it a nebula within our own galaxy, or something far grander? The answer began to take shape in the early 20th century, thanks to the work of Edwin Hubble. Using the powerful Hooker telescope at Mount Wilson Observatory, Hubble made a groundbreaking discovery. He observed a special kind of star in Andromeda called a sleepaid variable, which allowed him to measure its distance. What he found was astonishing. Andromeda was not part of the Milky Way. It was an entirely separate galaxy, located an incredible 2.5 million light-years away. This revelation shattered the long-held belief that the Milky Way was the entire universe. Suddenly, the cosmos expanded in our minds, revealing a universe filled with countless galaxies, each one a vast island of stars. This discovery didn't just change astronomy, it changed how we see ourselves. No longer were we at the center of everything. Instead, we were part of a much larger, more mysterious tapestry. Andromeda became the first galaxy to show us that the universe is far more immense and wondrous than we ever imagined. As we continue our journey, let's keep in mind how this single discovery opened the door to understanding the true scale of the cosmos. Now, let's take a moment to truly grasp the immense scale of the Andromeda Galaxy. Picture this, a sprawling cosmic city of stars, stretching across an unimaginable distance. Andromeda is not just big, it's colossal. To put it into perspective, our Milky Way is home to roughly 200 to 400 billion stars, but Andromeda dwarfs even that. It contains over 1 trillion stars, each one a sun like our own, with its own potential worlds and mysteries. That's more than double the number of stars in our galaxy, making Andromeda a true giant in the cosmic neighborhood. But its size isn't the only thing that leaves us in awe. Andromeda sits an astonishing 2.5 million light years away from us. To understand just how far that is, imagine light, the fastest thing in the universe, traveling at a speed of 186,000 miles per second. Even at that incredible speed, it would take 2.5 million years for light to cross the distance between us and Andromeda. That means when we look at Andromeda today, we're seeing it as it was 2.5 million years ago, a snapshot of a time when early humans were just beginning to walk the Earth. Andromeda's vastness doesn't stop at its stars. Its diameter spans approximately 220,000 light years, making it significantly larger than the Milky Way, which measures about 100,000 light years across. To visualize this, think of 2 spiraling disks of light, one nearly twice the size of the other, floating in the darkness of space. Andromeda's sheer scale is a reminder of how small we are in the grand scheme of the universe, yet how connected we are to its wonders. As we continue to explore, let's carry this sense of awe with us, knowing that Andromeda is not just a distant neighbor. It's a testament to the boundless beauty and mystery of the cosmos. Now, let's turn our gaze to the intricate structure of the Andromeda Galaxy, a masterpiece of cosmic architecture. At its heart lies a brilliant central bulge, a dense cluster of stars that glows with a warm, golden light. This bulge is the galaxy's core, a bustling hub where stars are packed tightly together, creating a luminous beacon that anchors the entire structure. Surrounding this central bulge are the galaxy's iconic spiral arms, vast, sweeping arcs of stars, gas, and dust that spiral outward like the arms of a cosmic pinwheel. These arms are not just beautiful, they are dynamic regions where new stars are born, lighting up the galaxy with their youthful energy. But Andromeda's structure doesn't end there. Encircling the entire galaxy is a faint, diffuse halo, a vast sphere of older stars, dark matter, and globular clusters. This halo extends far beyond the visible disk of the galaxy, creating an invisible boundary that holds everything together. The halo is a relic of Andromeda's ancient past, a reminder of the galaxy's formation billions of years ago. Together, these components, the central bulge, the spiral arms, and the halo, create a harmonious balance, giving Andromeda its breathtaking appearance and setting it apart from other galaxies in the universe. What makes Andromeda's structure particularly fascinating is how it compares to other galaxies. While many spiral galaxies share similar features, Andromeda's spiral arms are more tightly wound, giving it a more compact and defined look. Its central bulge is also larger and more pronounced than those found in smaller galaxies, a testament to its immense size and mass. Andromeda's halo, too, is unique, containing a higher concentration of globular clusters than most other galaxies. These subtle differences make Andromeda not just a neighbor in space, but a cosmic marvel that continues to captivate astronomers and stargazers alike. As we marvel at Andromeda's structure, we're reminded of the intricate beauty that exists in the universe. Each component, from the glowing core to the sweeping arms and the faint halo, tells a story of creation, evolution, and the enduring dance of stars. Andromeda's structure is more than just a collection of parts. It's a living, breathing entity, a testament to the wonders that await us in the depths of space. Now, let's journey into the future, where one of the most dramatic events in the cosmos awaits. In about 4.5 billion years, the Andromeda Galaxy and our own Milky Way are destined to collide. This monumental event, predicted by astronomers, will be a slow, graceful dance of two galaxies drawn together by the irresistible pull of gravity. Picture this: two colossal spirals, each containing hundreds of billions of stars, inching closer and closer until they finally merge into one. When this cosmic collision begins, it won't be a chaotic crash, as one might imagine. Instead, it will unfold over billions of years, a gradual and almost poetic merging of two galactic giants. As Andromeda and the Milky Way approach each other, their immense gravitational forces will stretch and distort their shapes, pulling stars and gas into long, luminous streams. The night sky, as seen from Earth, will transform into a breathtaking spectacle. Stars from Andromeda will begin to appear brighter and more numerous, painting the heavens with a dazzling array of new lights. But what happens when the galaxies finally collide? The stars within them are so far apart that direct collisions between stars are incredibly rare. Instead, the galaxies will pass through each other, their structures intertwining like threads in a cosmic tapestry. Over time, the gravitational forces will pull them back together, and they will merge into a single, larger galaxy. This new galaxy, often referred to as Milkomda or Milkdromda, will be an elliptical galaxy, a smooth, rounded structure devoid of the spiral arms we see today. The collision will also trigger a burst of new star formation, as clouds of gas and dust are compressed, igniting the birth of countless new stars. However, this flurry of activity will eventually settle, and the new galaxy will enter a quieter phase, its stars aging and its light dimming over billions of years. While this event may sound cataclysmic, it's important to remember that the vast distances between stars mean that life on Earth, if it still exists, is unlikely to be directly affected. The Sun and its planets will likely be flung into a new orbit within the merged galaxy, but the chances of our solar system being disrupted are slim. This collision is a reminder of the dynamic and ever-changing nature of the universe. Galaxies like Andromeda and the Milky Way are not static islands in space, but living, evolving entities, constantly shaped by the forces of gravity and time. As we look to the future, we can only imagine the wonders that await in this cosmic dance, a testament to the grandeur and mystery of the universe. Now, let's turn our attention to the heart of the Andromeda Galaxy, where a mysterious and powerful force resides, a supermassive black hole. This colossal entity, known as M31 star, sits at the very center of Andromeda, exerting an immense gravitational pull that shapes the galaxy's structure and movement. With a mass estimated to be around 100 million times that of our Sun, this black hole is a true titan, anchoring the galaxy and influencing the orbits of stars and gas clouds around it. Much like the Milky Way's own supermassive black hole, Sagittarius A star, M31 star, plays a crucial role in its galaxy's dynamics. Both black holes are central hubs of activity, drawing in matter and occasionally flaring up as they consume gas and dust. However, there are key differences between the two. While Sagittarius, a star, is relatively quiet and less active, M31 star has shown signs of more frequent activity, with bursts of energy that light up its surroundings. This suggests that Andromeda's black hole may be feeding more actively, pulling in material at a higher rate than its Milky Way counterpart. The presence of these supermassive black holes raises fascinating questions about how galaxies form and evolve. They are not just destructive forces, but also creators, as the energy they release can trigger star formation and shape the structure of their galaxies. In Andromeda, M31 star's influence extends far beyond its immediate vicinity, affecting the motion of stars and gas throughout the galaxy. It's a reminder that even the most enigmatic objects in the universe play a vital role in the cosmic dance of creation and destruction. As we compare these two black holes, we gain a deeper understanding of the similarities and differences between Andromeda and the Milky Way. Both galaxies are shaped by the immense gravitational forces at their cores, yet each has its own unique story to tell. The study of these supermassive black holes not only sheds light on the nature of Andromeda and the Milky Way, but also helps us unravel the mysteries of galaxy formation and evolution across the universe. With this glimpse into the heart of Andromeda, we're reminded of the incredible forces at work in the cosmos, shaping galaxies and driving the endless cycle of creation and transformation. Next, we'll explore the vibrant regions of star formation within Andromeda, where new stars are born and the galaxy's beauty truly shines. Now, let's journey to the vibrant regions of Andromeda, where the magic of star formation unfolds. Scattered across the galaxy are vast clouds of gas and dust, known as nebulae, which serve as the cosmic nurseries for new stars. These glowing clouds, illuminated by the light of young, hot stars, are some of the most breathtaking sights in the universe. Within these nebulae, gravity pulls together gas and dust, creating dense pockets that eventually ignite into stars, lighting up the galaxy with their brilliance. One of the most famous star-forming regions in Andromeda is the Andromeda Nebula, a sprawling expanse of gas and dust where countless stars are born. Here, the interplay of gravity, radiation, and magnetic fields shapes the birth of stars, each one a beacon of light in the galaxy's vast expanse. As these young stars begin to shine, they heat up the surrounding gas, causing it to glow in stunning hues of red, blue, and purple. This process not only adds to the galaxy's beauty, but also fuels its ongoing evolution. In addition to nebulae, Andromeda is home to numerous star clusters, groups of stars bound together by gravity. These clusters come in two main types: open clusters, which are loose groupings of young stars, and globular clusters, which are dense, spherical collections of older stars. Open clusters often form within nebulae, where the same clouds of gas and dust give rise to multiple stars at once. Over time, these clusters may drift apart, but their formation leaves a lasting mark on the galaxy's structure and appearance. The process of star formation in Andromeda is not just a spectacle of light and color. It's also a key driver of the galaxy's evolution. As new stars are born, they enrich their surroundings with heavier elements forged in their cores, paving the way for future generations of stars and even planets. This cycle of creation and renewal ensures that Andromeda remains a dynamic and ever-changing galaxy, full of life and energy. As we marvel at these star-forming regions, we're reminded of the delicate balance between chaos and beauty in the cosmos. The birth of stars is a violent, turbulent process, yet it gives rise to some of the most serene and awe-inspiring sights in the universe. Next, we'll turn our gaze to Andromeda's satellite galaxies, the smaller companions that orbit this cosmic giant and add to its rich tapestry of stars and stories. Now, let's shift our focus to the smaller companions that dance around Andromeda, adding depth and intrigue to its cosmic neighborhood. These satellite galaxies, like M32 and M110, are more than just celestial bystanders. They play a vital role in shaping the story of Andromeda itself. M32, one of Andromeda's closest companions, is a compact elliptical galaxy that orbits its larger neighbor at a relatively close distance. Despite its small size, M32 is a fascinating object, packed with stars and showing signs of intense gravitational interactions with Andromeda. These interactions have likely stripped away much of M32's outer layers, leaving behind a dense core that continues to intrigue astronomers. Its proximity to Andromeda makes it a key player in understanding how larger galaxies influence their smaller neighbors. Then there's M110, another prominent satellite galaxy, which presents a stark contrast to M32. M110 is a dwarf elliptical galaxy, slightly larger and more diffuse, with a more relaxed structure. It orbits Andromeda at a greater distance, allowing it to retain more of its original shape and composition. M110's presence adds a layer of complexity to Andromeda's cosmic neighborhood, showcasing the diversity of galaxies that can exist even within a single system. Together, M32 and M110 offer a glimpse into the dynamic relationships that define galactic interactions. These satellite galaxies are not just passive companions, they actively contribute to Andromeda's evolution. Through gravitational interactions, they influence the distribution of stars and gas within Andromeda, sometimes triggering bursts of star formation or altering the galaxy's structure. In turn, Andromeda's immense gravity shapes the fate of its satellites, pulling them closer over time and sometimes even consuming them entirely. This cosmic dance between Andromeda and its satellites is a reminder of the interconnected nature of the universe. Beyond M32 and M110, Andromeda is surrounded by a host of smaller satellite galaxies, each with its own unique characteristics. These galaxies, though less prominent, add to the richness of Andromeda's cosmic neighborhood, creating a vibrant tapestry of stars, gas, and dark matter. Together, they form a galactic family, bound by gravity and shared history, that continues to evolve over billions of years. As we explore these satellite galaxies, we gain a deeper appreciation for the complexity and beauty of Andromeda's cosmic environment. They remind us that even in the vastness of space, no galaxy exists in isolation. Next, we'll delve into the mythological origins of Andromeda's name, uncovering the ancient stories that connect this galaxy to human imagination and culture. Now, let's journey from the scientific wonders of Andromeda's satellite galaxies to the realm of myth and imagination, where the galaxy's name finds its roots in an ancient tale of heroism and celestial beauty. The Andromeda Galaxy is named after the princess Andromeda from Greek mythology, a figure whose story has captivated storytellers and stargazers for centuries. According to the myth, Andromeda was the daughter of King Cepheus and Queen Cassiopeia, rulers of the ancient kingdom of Ethiopia. Cassiopeia, known for her vanity, boasted that her daughter's beauty surpassed even that of the sea nymphs, the Nereids. This arrogance angered Poseidon, the god of the sea, who sent a sea monster, Cetus, to ravage the kingdom. To appease the gods and save his people, King Cepheus was told to chain Andromeda to a rock by the sea as a sacrifice to the monster. As fate would have it, the hero Perseus, fresh from his victory over the Gorgon Medusa, happened upon the scene. Struck by Andromeda's beauty and moved by her plight, Perseus vowed to save her. Using Medusa's severed head, which turned onlookers to stone, he defeated the sea monster and freed Andromeda. The two were later married, and their story became a symbol of courage, love, and the triumph of good over evil. This ancient tale has left its mark not only in mythology, but also in the night sky. The constellations of Andromeda, Perseus, Cassiopeia, Cepheus, and even Cetus are all immortalized among the stars, forever telling the story of this dramatic encounter. The Andromeda Galaxy, with its ethereal glow and vast expanse, seems to echo the princess's celestial beauty, as if the heavens themselves have preserved her legacy. The connection between the galaxy and its mythological namesake is more than just a coincidence of naming. It reflects humanity's timeless fascination with the stars and our desire to weave stories into the fabric of the cosmos. The Andromeda Galaxy, with its shimmering spiral arms and distant light, invites us to imagine not only the scientific mysteries it holds, but also the myths and dreams it has inspired across cultures and generations. As we gaze at Andromeda in the night sky, we are reminded of the power of storytelling to bridge the gap between the heavens and earth. The galaxy's beauty and grandeur continue to inspire awe, just as the tale of Andromeda and Perseus has inspired countless generations. Next, we'll turn our attention to the practical side of stargazing, exploring how you can spot the Andromeda Galaxy from your own backyard and connect with this celestial wonder firsthand. Now that we've explored the myths and stories tied to the Andromeda Galaxy, let's bring our gaze back to Earth and discover how you can witness this cosmic wonder for yourself. Observing the Andromeda Galaxy from your own backyard is an experience that connects you to the vastness of the universe in a deeply personal way. To begin, the best time to spot Andromeda is during the autumn and winter months, particularly from September to February, when the galaxy is high in the night sky. During these months, the skies are often clearer, and the longer nights provide ample opportunity for stargazing. Look for the constellation Andromeda, which is part of the larger Perseus family of constellations. You can find it by locating the Great Square of Pegasus, a prominent asterism in the autumn sky. From there, trace a line of stars leading away from the square, and you'll find the Andromeda Galaxy nestled among them. while Andromeda is visible to the naked eye under dark skies. Using binoculars or a small telescope will significantly enhance your view. Even a basic pair of binoculars will reveal the galaxy's faint, elongated glow, while a telescope can bring out more detail, such as its bright core and hints of its spiral structure. For the best experience, head to a location away from city lights, where light pollution is minimal. Dark sky parks or rural areas are ideal for this purpose. If you're new to stargazing, consider using a star map or a smartphone app designed for astronomy. These tools can help you navigate the night sky and pinpoint Andromeda with ease. Apps like Sky Safari or Stellarium provide real-time sky maps and can guide you to the galaxy's exact location. Patience is key when observing celestial objects. Allow your eyes to adjust to the darkness for at least 20 minutes and take your time to scan the area. The Andromeda Galaxy may appear as a faint smudge at first, but as your eyes adapt, its ethereal glow will become more pronounced. Remember, the light you're seeing from Andromeda has traveled for 2.5 million years to reach your eyes. Every glimpse of this galaxy is a journey through time, offering a humbling reminder of the universe's vast scale. As we continue our exploration, we'll delve into the role Andromeda has played in advancing our understanding of the cosmos, uncovering how this galactic neighbor has shaped the field of astronomy. But for now, take a moment to step outside, look up, and let the Andromeda Galaxy inspire your own connection to the stars. Now that we've explored how to observe the Andromeda Galaxy from Earth, let's turn our attention to the profound impact this galactic neighbor has had on the field of astronomy. Andromeda has been a cornerstone in our understanding of the universe, offering insights that have reshaped the way we see the cosmos. One of the most significant contributions of Andromeda to astronomy is its role in confirming the existence of galaxies beyond our own. Before Edwin Hubble's groundbreaking observations in the early 20th century, many believed the Milky Way was the entirety of the universe. Hubble's study of Andromeda revealed that it was not a nebula within our galaxy, but an entirely separate galaxy, millions of light years away. This discovery fundamentally changed our perspective, revealing a universe filled with countless galaxies, each a vast island of stars. Andromeda has also been instrumental in advancing our understanding of dark matter. Observations of the galaxy's rotation curve, the way stars and gas move within it, showed that the visible matter alone couldn't account for the gravitational forces at play. This discrepancy led astronomers to propose the existence of dark matter, an invisible substance that makes up a significant portion of the universe's mass. By studying Andromeda, scientists have been able to map the distribution of dark matter and refine theories about its nature and role in the cosmos. Another key area where Andromeda has contributed is in the study of the universe's expansion. By measuring the distances and velocities of galaxies, including Andromeda, astronomers have been able to refine the Hubble constant, the rate at which the universe is expanding. This has provided critical data for understanding the age and future of the universe, as well as the forces driving its growth. Andromeda has also served as a laboratory for studying star formation and galactic evolution. Its spiral structure rich with star-forming regions, offers a close-up view of processes that shape galaxies over billions of years. By comparing Andromeda to the Milky Way, astronomers can better understand the similarities and differences between spiral galaxies, shedding light on how galaxies form, evolve, and interact. As we continue to study Andromeda, it remains a vital source of knowledge, helping us piece together the story of the universe, from its role in confirming the existence of other galaxies to its contributions to our understanding of dark matter and cosmic expansion. Andromeda has been a guiding light in the field of astronomy. Next, we'll explore the diverse stellar populations within Andromeda, uncovering the stories written in its stars and the secrets they hold about the galaxy's past and future. Now, let's turn our gaze to the stars themselves, the countless points of light that make up the Andromeda Galaxy. Within its vast expanse, Andromeda is home to a dazzling array of stellar populations, each telling a unique story about the galaxy's history and evolution. From the fiery brilliance of young, hot blue stars to the steady glow of older, cooler red giants, these stars paint a vivid picture of Andromeda's cosmic journey. At the heart of Andromeda's spiral arms, you'll find regions teeming with young, massive stars. These blue giants burn brightly and live fast, their intense heat and energy lighting up the surrounding gas and dust. Their short lifespans, often just a few million years, mean they are found in areas of active star formation, where the galaxy's raw materials are being forged into new suns. These stars are like the vibrant youth of Andromeda, full of energy and shaping the galaxy's present. In contrast, the older stars of Andromeda, particularly the red giants, tell a quieter but equally important story. These stars have burned through their fuel over billions of years, swelling into cooler, larger forms as they near the end of their lives. They are often found in the galaxy's central bulge and its halo, regions that hold clues to Andromeda's earliest days. The presence of these ancient stars suggests that the galaxy's core formed first, with the spiral arms and outer regions developing later. Between these extremes lies a rich tapestry of stars in various stages of life. Yellow dwarfs, like our own sun, and white dwarfs, the remnants of stars that have exhausted their fuel, add to the diversity. Each type of star contributes to the galaxy's overall structure and dynamics, influencing everything from its rotation to its chemical composition. By studying these stellar populations, astronomers can piece together a timeline of Andromeda's formation and growth, revealing how it has changed over billions of years. One of the most fascinating aspects of Andromeda's stars is their chemical makeup. Younger stars tend to be richer in heavier elements, like iron and carbon, which were forged in the hearts of earlier generations of stars and scattered into space by supernova. Older stars, on the other hand, are often metal-poor, reflecting the simpler composition of the early universe. This difference in chemistry provides a window into the galaxy's past, showing how it has evolved and enriched itself over time. As we explore Andromeda's stellar populations, we're not just looking at individual stars, we're uncovering the story of an entire galaxy. Each star, whether young and blazing or old and fading, is a piece of the puzzle, helping us understand how Andromeda came to be and where it might be headed. Next, we'll delve into the swirling clouds of dust and gas that serve as the raw materials for these stars, exploring how they shape the galaxy's ongoing evolution. Now, let's drift into the swirling clouds of dust and gas that fill the spaces between Andromeda's stars. These interstellar clouds are more than just cosmic decorations. They are the very building blocks of new stars, the raw materials from which the galaxy's future is forged. Picture vast, shimmering veils of gas, glowing faintly in hues of red and blue as they twist and dance through the darkness. These clouds are alive with potential, holding within them the seeds of countless stars yet to be born. The dust in Andromeda is not the kind you might find on Earth. Instead, it's made up of tiny particles, some no larger than a grain of sand, composed of carbon, silicon, and other elements. These particles scatter and absorb light, creating the dark, shadowy lanes that streak across the galaxy's spiral arms. But within these seemingly empty spaces, something extraordinary is happening. The dust and gas are slowly collapsing under their own gravity, heating up and igniting the fires of new stars. It's a process as old as the universe itself, yet it continues to shape Andromeda's destiny. The gas clouds, primarily made of hydrogen, are the true lifeblood of the galaxy. They glow with a soft, ethereal light, energized by the radiation from nearby stars. In some regions, these clouds are so dense that they form massive nebulae, like the famous Orion Nebula in our own Milky Way. These nebulae are stellar nurseries, where stars are born in clusters, lighting up the surrounding gas with their brilliance. The interplay of light and shadow within these clouds creates a breathtaking tapestry, a reminder of the beauty and chaos of the cosmos. As we gaze at these swirling clouds, we're witnessing the cycle of creation and destruction that defines the universe. The same clouds that give birth to stars will one day be replenished by the material expelled from dying stars, continuing the cycle anew. It's a dance of matter and energy, a cosmic rhythm that has played out for billions of years and will continue for billions more. Next, we'll turn our attention to the dense, spherical star clusters that orbit Andromeda, exploring how these ancient collections of stars add to the galaxy's rich tapestry and deepen our understanding of its history. Now, let's shift our gaze to the ancient guardians of Andromeda, its globular clusters. These dense, spherical collections of stars are like cosmic time capsules, holding secrets of the galaxy's earliest days. Imagine thousands, even millions of stars packed tightly together, orbiting the heart of Andromeda in a slow, graceful dance. These clusters are not just beautiful to behold, they are key to unlocking the story of how Andromeda formed and evolved over billions of years. Globular clusters are among the oldest structures in the universe, with some dating back nearly as far as the Big Bang itself. They are like living fossils, preserving the conditions of the early universe in their tightly bound stars. Unlike the younger, more scattered stars in Andromeda's spiral arms, the stars in these clusters are ancient, often glowing with a cooler, reddish hue. Their age and composition tell us about the environment in which they formed, offering clues about the galaxy's infancy. These clusters are not just relics of the past, they play an active role in the galaxy's present. Their immense gravity influences the motion of stars and gas around them, shaping the larger structure of Andromeda. Some clusters even orbit far beyond the galaxy's visible disk, tracing paths through the dark matter halo that surrounds it. By studying their movements, astronomers can map the invisible forces that hold Andromeda together, revealing the hidden architecture of the cosmos. But perhaps the most fascinating aspect of globular clusters is their diversity. While they may appear similar at first glance, each cluster has its own unique story. Some are rich in heavy elements, suggesting they formed from gas enriched by generations of stars. Others are nearly pristine, composed of the simplest elements forged in the early universe. This variety paints a vivid picture of Andromeda's history, showing how it grew and changed over time. As we marvel at these ancient star clusters, we're reminded of the interconnectedness of the universe. They are not just distant specks of light, they are part of the same cosmic web that binds us all. Next, we'll delve into the mysterious dark matter halo that envelops Andromeda, exploring how this invisible force shapes the galaxy's destiny. Now, let's turn our attention to the unseen force that shapes Andromeda's very existence, its dark matter halo. This invisible shroud, though undetectable by conventional means, plays a crucial role in the galaxy's structure and movement. Dark matter, a mysterious substance that neither emits nor reflects light, makes up the majority of the universe's mass. In Andromeda, it forms a vast, diffuse halo that extends far beyond the galaxy's visible stars and gas, enveloping it in an invisible embrace. The dark matter halo is like the hidden skeleton of Andromeda, providing the gravitational framework that holds the galaxy together. Without it, the stars and gas we see would simply drift apart, unable to maintain the galaxy's intricate spiral structure. This invisible force not only keeps Andromeda intact, but also influences the motion of its stars, gas, and even its satellite galaxies. By studying the way these visible components move, astronomers can map the distribution of dark matter, revealing the unseen architecture that governs the galaxy's behavior. One of the most fascinating aspects of dark matter is its ability to shape the cosmos on a grand scale. In Andromeda, the halo's immense gravity affects the orbits of globular clusters and satellite galaxies, pulling them into paths that trace the contours of this invisible web. These movements provide critical clues about the halo's size, mass, and density, helping scientists piece together a clearer picture of how dark matter operates. It's like solving a cosmic puzzle, where the pieces are the visible objects, and the solution lies in the unseen forces guiding them. But what exactly is dark matter? Despite decades of research, its true nature remains one of the greatest mysteries in astronomy. It doesn't interact with light or ordinary matter in the way we're familiar with, making it incredibly difficult to detect directly. Yet its presence is undeniable, inferred from the gravitational effects it has on the visible universe. In Andromeda, the dark matter halo is estimated to be many times more massive than all the stars and gas combined, a testament to its dominance in shaping the galaxy's destiny. As we ponder the mysteries of dark matter, we're reminded of how much of the universe remains hidden from our view. This invisible halo is not just a feature of Andromeda, it's a fundamental part of the cosmic tapestry, influencing galaxies across the universe. Next, we'll explore Andromeda's place within its cosmic neighborhood, the local group, and how it interacts with other galaxies in this vast celestial community. Now, let's step back and take a broader look at Andromeda's place in the universe. Nestled within what astronomers call the local group, Andromeda is part of a cosmic neighborhood that includes our own Milky Way and roughly 54 other galaxies. This collection of galaxies, bound together by gravity, forms a small but fascinating corner of the universe, where interactions and influences shape the destiny of its members. The local group spans about 10 million light-years, a relatively modest distance on the cosmic scale. Within this group, Andromeda and the Milky Way are the two largest galaxies, each surrounded by their own entourage of smaller satellite galaxies. These smaller companions, like M32 and M110, orbiting Andromeda, are drawn into the gravitational dance of their larger neighbors, creating a dynamic and ever-changing celestial community. Gravity is the invisible thread that ties these galaxies together. Over billions of years, the gravitational pull between Andromeda and the Milky Way has been drawing them closer, setting the stage for their eventual collision. But even before that dramatic event, the galaxies in the local group are constantly influencing one another. Tidal forces from these interactions can stretch and distort galaxies, triggering bursts of star formation, or even stripping away gas and stars to form long, glowing streams in the void of space. One of the most intriguing aspects of the local group is its diversity. While Andromeda and the Milky Way are spiral galaxies, the group also includes elliptical galaxies, irregular galaxies, and dwarf galaxies of various shapes and sizes. Each type of galaxy tells a different story about how stars, gas, and dark matter come together to form these cosmic structures. By studying the local group, astronomers gain insights into the processes that shape galaxies across the universe. The interactions within the local group also provide a glimpse into the future. As Andromeda and the Milky Way continue their slow but inevitable approach, their gravitational tug-of-war will reshape both galaxies, eventually merging them into a single, larger galaxy. This cosmic dance is not unique to our local group. It's a common occurrence in the universe, where galaxies collide, merge, and evolve over time. As we explore Andromeda's cosmic neighborhood, we're reminded of the interconnectedness of the universe. Every galaxy, no matter how small or distant, plays a role in the grand tapestry of the cosmos. Next, we'll turn our gaze to the future, imagining what lies ahead for Andromeda and the local group as they continue their journey through the vast expanse of space. As we peer into the distant future, the story of Andromeda unfolds like a cosmic epic, filled with dramatic transformations and breathtaking events. One of the most anticipated chapters in this saga is the collision between Andromeda and our own Milky Way. In about 4.5 billion years, these two galactic giants will meet in a slow, majestic dance, drawn together by the irresistible pull of gravity. When this cosmic encounter begins, it won't be a violent crash, but rather a graceful merging, as the vast distances between stars mean that direct collisions are unlikely. Instead, the galaxies will pass through each other, their gravitational forces stretching and twisting their shapes into spectacular, glowing arcs of stars and gas. Over hundreds of millions of years, they will swing past each other, their structures warped and reshaped, before finally settling into a single, larger galaxy. Astronomers have even given this future galaxy a name, Milkomda. Milkomda will be a colossal elliptical galaxy, its once spiral arms now blended into a smooth, glowing sphere of stars. The night sky for many surviving planets within this new galaxy will be utterly transformed. Instead of the familiar band of the Milky Way, the heavens will be filled with a dense, golden haze of stars, a testament to the merger of two cosmic titans. But the story doesn't end there. As Milkomda settles into its new form, the universe itself will continue to evolve. Billions of years from now, the expansion of the universe will carry other galaxies farther and farther away, leaving Milkomda as an isolated island in an ever-darkening cosmos. The stars within it will continue to burn, grow old, and fade, while new stars will form from the remnants of the old. Yet, even as the universe grows colder and more distant, the legacy of Andromeda and the Milky Way will endure. Their merger will stand as a reminder of the dynamic, ever-changing nature of the cosmos, where even the largest structures are not permanent, but part of an endless cycle of creation and transformation. As we imagine this distant future, we're reminded of the fleeting nature of our own existence in the grand timeline of the universe. And yet, in the vastness of space and time, the story of Andromeda and the Milky Way is a testament to the beauty and resilience of the cosmos, a story that continues to unfold even as we watch from our tiny corner of the universe. Next, we'll turn our attention to the light we see from Andromeda, a light that has traveled across millions of years to reach us, offering a glimpse into the galaxy's past and its enduring mysteries. Now, let's shift our gaze to the light that connects us to Andromeda, a light that has journeyed across an unimaginable distance to reach our eyes. The light we see from the Andromeda Galaxy today began its journey 2.5 million years ago, long before humans walked the Earth. When we look at Andromeda, we're not just observing a distant galaxy. We're peering into the past, witnessing a snapshot of what it looked like millions of years ago. This light, traveling at the incredible speed of light itself, carries with it the story of Andromeda as it was in an era when our ancestors were just beginning to shape their world. This concept of looking back in time is one of the most profound ideas in astronomy. Every time we observe a distant galaxy, we're essentially using light as a time machine, allowing us to glimpse the universe as it once was. For Andromeda, this means we're seeing it not as it is today, but as it was when its light first began its journey toward us. Imagine what might have changed in Andromeda during those 2.5 million years. New stars may have been born, old ones may have faded, and its structure may have evolved in ways we can only speculate about. The light from Andromeda also reminds us of the vastness of space and the incredible scale of the universe. Even at the speed of light, it takes millions of years for that light to traverse the distance between galaxies. This immense span of time and space underscores just how small and fleeting our own existence is in the grand cosmic timeline. Yet, it also highlights the remarkable ability of human curiosity and technology to bridge these distances, allowing us to explore and understand the universe from our tiny corner of it. As we reflect on Andromeda's light, we're reminded that the universe is not just a place of immense scale, but also a place of deep history. Every beam of light from a distant galaxy carries with it a story, a piece of the cosmic puzzle that helps us piece together the history of the universe. Andromeda's light, in particular, offers us a unique window into the past, a chance to see a galaxy as it once was and to marvel at the timeless beauty of the cosmos. Next, we'll explore how the Andromeda Galaxy has inspired human creativity, leaving its mark on art, literature, and our collective imagination. Now, let's turn our attention to the ways the Andromeda Galaxy has sparked the human imagination, leaving its mark on art, literature, and the stories we tell about the cosmos. For centuries, the beauty and mystery of Andromeda have inspired creators to dream beyond the confines of Earth, weaving its celestial splendor into the fabric of human culture. In literature, Andromeda has often served as a symbol of the unknown, a distant realm that invites exploration and wonder. Science fiction writers, in particular, have been drawn to its vastness, imagining it as a setting for epic tales of interstellar travel and alien civilizations. Works like Isaac Asimov's The Andromeda Strain and Arthur C. Clarke's The Songs of Distant Earth have used the galaxy as a backdrop for stories that explore humanity's place in the universe. These narratives not only entertain, but also challenge us to think about the possibilities of life beyond our own galaxy. Artists, too, have been captivated by Andromeda's ethereal beauty. From intricate paintings to breathtaking digital renderings, creators have sought to capture its swirling spiral arms and glowing core. The galaxy's vibrant colors and dynamic structure have made it a favorite subject for space art, inspiring works that blend scientific accuracy with artistic expression. These pieces often evoke a sense of awe, reminding us of the galaxy's grandeur and our own smallness in the cosmos. Even in popular culture, Andromeda has found its way into films, television, and music. It has appeared in science fiction franchises like Star Trek and Star Wars, where it symbolizes the vastness of space and the endless possibilities of exploration. Musicians have also drawn inspiration from the galaxy, composing songs that reflect its mystery and majesty. Whether through lyrics or melodies, these works capture the emotional impact of gazing at a galaxy so distant, yet so familiar. The influence of Andromeda on culture goes beyond mere representation. It has shaped how we think about the universe and our place within it. By inspiring stories, art, and music, the galaxy has become a bridge between science and creativity, encouraging us to dream of what lies beyond the stars. It reminds us that the cosmos is not just a place of scientific discovery, but also a source of endless inspiration. As we reflect on Andromeda's cultural impact, we're reminded of the power of the night sky to ignite our imagination. From ancient myths to modern masterpieces, the galaxy continues to inspire us to look up and wonder. Next, we'll delve into the mysteries that still surround Andromeda, exploring the questions that keep astronomers and dreamers alike searching for answers. As we continue our journey through the wonders of the Andromeda Galaxy, we now turn to the mysteries that still linger, the questions that keep astronomers and dreamers alike searching for answers. Despite all we've learned about our galactic neighbor, there are still secrets hidden within its vast expanse, waiting to be uncovered. One of the most intriguing mysteries surrounding Andromeda is the nature of its dark matter. This invisible substance, which makes up a significant portion of the galaxy's mass, remains one of the greatest enigmas in modern astronomy. Scientists know that dark matter exists because of its gravitational effects on stars and gas, but its true nature is still unknown. What is it made of? How does it interact with the visible matter we can see? These questions drive ongoing research as astronomers use advanced tools and techniques to probe the hidden depths of Andromeda's dark matter halo. Another puzzle lies in the origins of Andromeda's satellite galaxies. These smaller galaxies, like M32 and M110, orbit Andromeda much like moons orbit a planet. But how did they come to be? Were they always part of Andromeda's cosmic neighborhood, or were they captured over time through gravitational interactions? Some theories suggest that these satellites may be remnants of ancient collisions, while others propose they formed independently and were later drawn into Andromeda's orbit. Unraveling their history could provide clues about the galaxy's past and the processes that shape galactic evolution. Then there's the question of Andromeda's central black hole. While we know it exists, much about its behavior and influence remains a mystery. How does it compare to the supermassive black hole at the heart of our own Milky Way? What role does it play in shaping the galaxy's structure and dynamics? Observations of Andromeda's core continue to shed light on these questions, but the answers are still far from complete. And let's not forget the galaxy's stellar populations. Why does Andromeda have such a diverse mix of stars, from young, hot blue stars to older, cooler red giants? What can these stars tell us about the galaxy's formation and evolution? By studying their composition and distribution, astronomers hope to piece together the story of how Andromeda came to be the stunning spiral we see today. These mysteries remind us that, even with all we've discovered, the Andromeda Galaxy still holds countless secrets. Every observation, every new piece of data, brings us closer to understanding this cosmic neighbor, but also raises new questions that push the boundaries of our knowledge. It's this ongoing quest for answers that makes astronomy so exciting, a never-ending journey of discovery that keeps us looking to the stars. As we ponder these unanswered questions, we're reminded of the vastness of the universe and the endless possibilities it holds. Next, we'll explore the vibrant colors of Andromeda, diving into the hues that paint its spiral arms and bring its beauty to life. Now, let's turn our gaze to the breathtaking colors that paint the Andromeda Galaxy, transforming it into a cosmic masterpiece. Imagine a canvas stretching across millions of light years, splashed with hues that tell the story of its stars, gas, and dust. The vibrant blues of young, hot stars dominate the spiral arms, their intense light cutting through the darkness like sapphires scattered across velvet. These stars, born from the galaxy's rich reservoirs of gas and dust, burn brightly and fiercely, their energy illuminating the surrounding space with a celestial glow. As we move inward toward the galaxy's core, the palette shifts. Here, the cooler, reddish tones of older stars take center stage. These aging giants, having burned through their fuel over billions of years, emit a softer, warmer light. Their crimson glow creates a striking contrast against the blue brilliance of their younger counterparts, giving Andromeda a layered, almost three-dimensional appearance. But the colors don't stop there. Woven throughout the galaxy are delicate threads of pink and purple, the telltale signs of ionized hydrogen gas. These regions, often found in the spiral arms, are nurseries where new stars are born. The gas glows as it's energized by the intense radiation from nearby young stars, creating a cosmic tapestry of light and color. And then there's the faint, golden haze that surrounds Andromeda, a subtle yet mesmerizing feature. This glow comes from the countless stars that populate the galaxy's outer regions, their combined light creating a soft, ethereal backdrop. It's a reminder of the sheer scale of Andromeda, a galaxy so vast that even its faintest light can be seen from millions of light years away. Together, these colors tell the story of Andromeda's life, its birth, its evolution, and its ongoing transformation. They reveal the dynamic processes at work within the galaxy, from the fiery birth of new stars to the quiet fading of old ones. And they remind us that, even in the cold, dark expanse of space, there is beauty to be found, a symphony of light and color that captivates the imagination. As we marvel at Andromeda's vibrant palette, we're reminded of the artistry of the cosmos. Next, we'll imagine the galaxy as a dancer in the vast cosmic ballet, moving gracefully through space and time, its colors swirling in an eternal performance. Now, let's step into the grand cosmic theater, where the Andromeda Galaxy takes center stage as a graceful dancer in an endless ballet. Picture it twirling through the vast expanse of space, its spiral arms sweeping outward like the flowing fabric of a dancer's gown. This majestic movement isn't just for show, it's a reflection of the galaxy's rotation, a slow and steady pirouette that takes hundreds of millions of years to complete. As Andromeda spins, it interacts with the space around it, pulling in smaller galaxies and cosmic material, much like a dancer drawing in their surroundings to enhance their performance. These interactions shape its structure, adding to the complexity and beauty of its form, but the most dramatic moment in Andromeda's dance is yet to come. In about 4.5 billion years, it will perform its final act, a breathtaking collision with our own Milky Way. This cosmic merger won't be a chaotic crash, but rather a slow, elegant intertwining of two galaxies. Imagine two dancers coming together, their movements blending into one as they create something entirely new. The stars within Andromeda and the Milky Way will pass by one another, their paths bending and weaving in a celestial choreography. Over time, the two galaxies will merge, forming a single, larger galaxy, a cosmic masterpiece born from their union. As we watch this dance unfold, we're reminded of the dynamic nature of the universe. Galaxies aren't static. They're alive with motion, constantly evolving and interacting in ways that shape the cosmos. Andromeda's dance is a testament to the beauty and complexity of the universe, a reminder that even in the vastness of space, there is rhythm and grace. Next, we'll reflect on Andromeda's role in the grand tapestry of the universe, exploring how this galactic neighbor helps us understand the origins and fate of galaxies across the cosmos. As we turn our gaze from Andromeda's cosmic dance, let's take a moment to consider its profound role in the universe. This magnificent galaxy isn't just a neighbor in space, it's a key to unlocking some of the deepest mysteries of the cosmos. By studying Andromeda, astronomers have gained invaluable insights into how galaxies form, evolve, and ultimately shape the universe we inhabit. Andromeda serves as a cosmic laboratory, offering a close-up view of processes that occur across the universe. Its structure, star populations, and interactions with smaller galaxies provide clues about the early stages of galactic formation. For instance, the way Andromeda's spiral arms are dotted with young, bright stars tells us about the conditions needed for star birth. Meanwhile, its older stars, nestled in the central bulge, reveal the galaxy's ancient history, like pages in a cosmic diary. But Andromeda's significance goes beyond its own story. It helps us understand the fate of galaxies on a universal scale. The impending collision between Andromeda and the Milky Way, for example, isn't just a local event. It's a glimpse into the future of many galaxies. Across the universe, galaxies are drawn together by gravity, merging and reshaping themselves over billions of years. By observing Andromeda, we can predict how these cosmic encounters might unfold elsewhere, painting a broader picture of galactic evolution. Moreover, Andromeda's dark matter halo, a vast invisible envelope that surrounds it, offers clues about one of the universe's greatest mysteries. Dark matter, though unseen, plays a crucial role in shaping galaxies and holding them together. By studying how Andromeda's dark matter influences its motion and structure, scientists can better understand this elusive substance and its impact on the cosmos. In the grand tapestry of the universe, Andromeda is more than just a thread. It's a vibrant patch that helps us see the bigger picture. Its story is intertwined with ours, not just as a galactic neighbor, but as a guide to understanding the origins and destiny of galaxies everywhere. As we continue to explore its secrets, we're reminded that the universe is a dynamic, ever-changing place, full of wonders waiting to be discovered. Next, we'll uncover some of Andromeda's hidden treasures, lesser-known features that make this galaxy even more fascinating and unique. Now, let's turn our attention to some of Andromeda's hidden treasures, those lesser-known features that make this galaxy even more captivating. Beyond its stunning spiral arms and bright stars, Andromeda holds secrets that continue to surprise and intrigue astronomers. One of its most fascinating features is its collection of unique star clusters. Unlike the globular clusters we've discussed earlier, Andromeda is home to a rare type of star cluster known as extended clusters. These clusters are larger and more diffuse than typical globular clusters, with stars spread out over a wider area. Scientists believe these extended clusters may have formed under unusual conditions, offering a glimpse into the galaxy's dynamic and complex history. Andromeda also boasts some of the most unusual gas clouds in the known universe. Among them is a massive cloud of hydrogen gas, stretching over thousands of light years. This cloud, known as the Andromeda Hydrogen Cloud, is thought to be the remnants of a smaller galaxy that was torn apart by Andromeda's gravitational pull. The cloud's swirling, ghostly appearance serves as a reminder of the galaxy's violent past and its ongoing interactions with its cosmic neighbors. Another hidden gem lies in Andromeda's outer regions, where astronomers have discovered a population of runaway stars. These stars, flung from their original locations by powerful gravitational interactions, race through space at incredible speeds. Some of these stars are even on trajectories that will eventually carry them out of the galaxy entirely, leaving behind a trail of light that tells the story of their dramatic escape. Andromeda's hidden treasures don't stop there. Deep within its spiral arms, astronomers have identified regions of intense star formation, where young stars are born in dazzling bursts of light. These stellar nurseries, often hidden behind thick clouds of dust, are some of the most active and energetic places in the galaxy. They remind us that even in a galaxy as ancient as Andromeda, new life is constantly being created. As we uncover these lesser-known features, we're reminded that Andromeda is a galaxy full of surprises. Its hidden treasures not only add to its beauty, but also deepen our understanding of the complex processes that shape galaxies. Each discovery brings us closer to unraveling the mysteries of the universe, one star, one cloud, and one cluster at a time. Next, we'll explore how Andromeda's cosmic symphony, the harmonious interplay of stars, gas, and dark matter, creates a dynamic and ever-changing galaxy. Now, let's step into the grand cosmic symphony of the Andromeda Galaxy, where stars, gas, and dark matter come together in a breathtaking dance of harmony and motion. Picture this galaxy as a vast orchestra, each element playing its part to create a masterpiece that spans millions of light years. At the heart of this symphony are the stars, the brilliant soloists that light up the stage. From the fiery, blue giants to the steady glow of red dwarfs, each star contributes its unique voice to the celestial melody. Their light weaves through the galaxy, creating patterns that shift and change over time, much like the notes of a musical composition. Then there are the swirling clouds of gas, the rhythm section of this cosmic orchestra. These clouds, rich with hydrogen and other elements, pulse with energy, forming the raw materials for new stars. They move in graceful arcs, their motions guided by the invisible hand of gravity, adding depth and texture to the symphony. And let's not forget the dark matter, the unseen conductor that holds everything together. Though invisible, its presence is felt in the way stars and gas move, shaping the galaxy's structure and ensuring that every element stays in perfect harmony. Without dark matter, this cosmic symphony would fall into chaos. Together, these components create a dynamic and ever-changing galaxy. Stars are born in dazzling bursts, gas clouds collide and merge, and dark matter orchestrates it all from the shadows. The result is a living, breathing entity that evolves over billions of years, its music echoing across the universe. As we listen to Andromeda's cosmic symphony, we're reminded of the intricate balance that governs the cosmos. Every star, every cloud, every particle of dark matter plays a role in this grand performance, a testament to the beauty and complexity of the universe. Next, we'll explore the profound connection between Andromeda and Earth, and how the atoms in our bodies may have originated in galaxies like this one. Now, let's turn our gaze closer to home and consider the extraordinary connection between Andromeda and Earth. It's a thought that might seem almost magical, but the atoms that make up your body, the air you breathe, and the ground beneath your feet may have once been part of a galaxy like Andromeda. Every element in the universe, from the carbon in your cells to the iron in your blood, was forged in the hearts of stars, scattered across the cosmos, and eventually found its way here. When we look at Andromeda, we're not just observing a distant galaxy, we're seeing a place that might have contributed to the very fabric of our existence. Stars and galaxies like Andromeda live, die, and explode in spectacular supernova, sending their elements out into the void. Over billions of years, these elements travel through space, carried by cosmic winds and gravitational tides, until they become part of new stars, planets, and even living beings. This means that the calcium in your bones, the oxygen in your lungs, and the nitrogen in your DNA could have originated in a galaxy millions of light years away. It's a humbling reminder that we are not separate from the universe, but deeply intertwined with it. The same forces that shaped Andromeda's stars and planets also shaped us, connecting us to the cosmos in ways that are both profound and beautiful. As we ponder this connection, we begin to see ourselves not just as inhabitants of Earth, but as children of the universe. The atoms within us carry the stories of ancient stars, distant galaxies, and the vast expanse of space. They remind us that we are part of something much larger, a cosmic tapestry woven together over billions of years. Next, we'll explore how the Andromeda Galaxy has inspired artists and creators, leaving its mark on human culture and imagination. As we shift our focus from the cosmic to the creative, let's explore how the Andromeda Galaxy has inspired artists across the centuries. Its ethereal beauty, with swirling arms of starlight and a glowing core, has captivated not only astronomers, but also painters, digital artists, and storytellers. Through their work, they've transformed this distant galaxy into something tangible, something that stirs the imagination and invites us to see the universe through their eyes. One of the earliest artistic depictions of Andromeda can be traced back to the Renaissance, when astronomers and artists began to merge science and art. Paintings from this era often depicted the galaxy as a celestial wonder, a shimmering jewel in the night sky. These works captured the awe and mystery of the cosmos, blending the known with the unknown in a way that resonated deeply with viewers. In the modern era, digital artists have taken this inspiration to new heights. Using advanced software and high-resolution images from telescopes, they've created breathtaking renderings of Andromeda that bring its intricate details to life. From the vibrant blues of young stars to the deep reds of aging giants, these digital masterpieces showcase the galaxy's dynamic beauty in ways that photographs alone cannot. They allow us to explore Andromeda up close, as if we were floating among its stars, witnessing the cosmic dance of light and color. But it's not just visual art that Andromeda has influenced. Writers and poets have also drawn inspiration from its grandeur, weaving its imagery into stories and verses that evoke a sense of wonder. In science fiction, Andromeda often serves as a backdrop for tales of exploration and discovery, a symbol of humanity's endless curiosity about the universe. These narratives remind us that the galaxy is not just a collection of stars and gas, but a source of endless inspiration, a canvas for our dreams and aspirations. Through art, Andromeda becomes more than a distant object in space. It becomes a reflection of our own creativity and imagination. It reminds us that the universe is not just something to be studied, but something to be felt, experienced, and celebrated. As we continue our journey, we'll delve into the role Andromeda has played in space exploration, imagining what future missions to our galactic neighbor might reveal. As we turn our gaze toward the future, let's dream of what it might be like to journey to the Andromeda Galaxy. While such a mission remains far beyond our current reach, the idea of exploring our galactic neighbor sparks the imagination and fuels our curiosity about what lies beyond the Milky Way. Imagine a spacecraft powered by technologies we can only begin to envision, embarking on a voyage across the vast expanse of 2.5 million light-years. What wonders might await us in Andromeda's star-filled arms? One of the most tantalizing possibilities is the discovery of new worlds. Andromeda is home to over 1 trillion stars, many of which likely host planets of their own. Some of these worlds could resemble Earth, with oceans, mountains, and perhaps even life. Imagine landing on a planet, orbiting a star in Andromeda's spiral arms, where the night sky is filled with the glow of 1 trillion suns. What kind of ecosystems might thrive in such a place? Could we find evidence of civilizations, ancient or new, that have gazed back at the Milky Way, just as we've gazed at them? Beyond planets, a mission to Andromeda could reveal secrets about the galaxy's structure and history. By studying its stars, gas clouds, and dark matter halo up close, we might uncover clues about how galaxies form and evolve. We could witness the birth of new stars in its vibrant nebulae, or observe the remnants of ancient supernovae, each telling a story of cosmic creation and destruction. Andromeda's central black hole, a behemoth with a mass millions of times that of our Sun, could offer insights into the mysterious forces that shape galaxies from within. Even the journey itself would be a monumental achievement, pushing the boundaries of human ingenuity and endurance. Traveling to Andromeda would require breakthroughs in propulsion, energy, and life support systems, as well as the ability to sustain a crew for generations. Yet, the challenges of such a mission could drive innovation, inspiring technologies that transform life on Earth and deepen our understanding of the universe. As we ponder these possibilities, we're reminded that the dream of exploring Andromeda is not just about reaching a distant galaxy. It's about the spirit of discovery that defines us as a species. It's about asking questions, seeking answers, and daring to imagine what lies beyond the horizon. While we may never set foot in Andromeda, the very act of dreaming about it brings us closer to understanding our place in the cosmos. Now, as we prepare to conclude our journey, let's reflect on the profound connection between Andromeda and Earth, and how this distant galaxy continues to inspire us to reach for the stars. As we drift further into the mysteries of Andromeda, let's pause for a moment to consider the profound silence that envelops the cosmos. Space, in its vast emptiness, is a realm of stillness, a quiet so deep it defies imagination. Yet within this silence, galaxies like Andromeda hum with activity, stars being born, black holes devouring matter, and cosmic winds shaping the fabric of existence. This contrast between the serene void and the vibrant life within galaxies is one of the universe's most captivating paradoxes. Picture the quiet of space as a vast, unbroken ocean, stretching endlessly in every direction. There are no sounds here, no echoes, no whispers, only the silent dance of light and shadow. And yet, within Andromeda, the galaxy pulses with energy. Its spiral arms are alive with the glow of newborn stars, while its core radiates with the power of a supermassive black hole. This duality, silence and motion, stillness and chaos, creates a harmony that is both awe-inspiring and deeply calming. The silence of space invites us to reflect on our own place in the universe. It reminds us that, despite the noise and busyness of our lives, there is a quiet center within us, all a place of stillness where we can find peace. Just as Andromeda thrives within the cosmic silence, we too can find balance amidst the chaos, drawing strength from the quiet moments that connect us to something greater. As we contemplate this cosmic silence, let it serve as a reminder of the beauty that exists in contrast. The universe is not just a place of extremes, light and dark, sound and silence, motion and stillness, but a tapestry woven from these opposing forces. Andromeda, with its vibrant heart and silent surroundings, embodies this balance, offering us a glimpse into the profound harmony of the cosmos. Now, as we prepare to conclude our journey, let's carry this sense of calm with us, allowing the quiet of space to inspire a deeper connection to the universe and to ourselves. As we bring our journey through the Andromeda Galaxy to a close, let's take a moment to reflect on the profound legacy it leaves behind. For centuries, Andromeda has been more than just a distant neighbor in the cosmos. It has been a beacon of inspiration, a window into the mysteries of the universe, and a testament to the boundless curiosity of humanity. Its light, traveling for 2.5 million years to reach us, carries not just the story of its own existence, but also the story of our relentless quest to understand the cosmos. Andromeda's legacy is one of discovery. It was the first galaxy to reveal to us that the universe extends far beyond the Milky Way, shattering our perception of a small, self-contained cosmos. Edwin Hubble's ground-breaking observations of Andromeda opened our eyes to the vastness of space, forever changing the way we see ourselves in the grand tapestry of the universe. Today, it continues to be a focal point for astronomers, offering clues about the nature of dark matter, the life cycles of galaxies, and the ultimate fate of our own Milky Way. But Andromeda's impact goes beyond science. It has inspired artists, writers, and dreamers, its ethereal beauty captured in paintings, poems, and stories. Its name, drawn from ancient mythology, connects us to the timeless human desire to find meaning in the stars. Andromeda reminds us that the universe is not just a place of cold, hard facts, but also a source of wonder and imagination, inviting us to dream of worlds beyond our own. Perhaps most importantly, Andromeda's legacy lies in its ability to unite us. It is a shared treasure, visible to stargazers across the globe, a reminder that we are all part of something far greater than ourselves. Whether we are peering through a telescope or simply gazing up at the night sky, Andromeda invites us to pause, to wonder, and to connect with the infinite. As we conclude this journey, let Andromeda's light continue to guide us not just as a distant galaxy, but as a symbol of our enduring curiosity and our unyielding desire to explore the unknown. Its legacy is a reminder that the universe is vast, mysterious, and full of beauty, waiting for us to uncover its secrets. And as we look to the stars, may we carry with us the same sense of wonder that Andromeda has inspired for generations. Thank you for joining us on this journey through the secrets of the Andromeda Galaxy. If you enjoyed this exploration, don't forget to like, subscribe, and hit the notification bell for more cosmic adventures. Until next time, keep looking up and let the stars remind you of the infinite possibilities that await. As we wrap up our exploration of the Andromeda Galaxy, let's take a moment to revisit the key themes that make this cosmic neighbor so extraordinary. From its discovery as the first galaxy beyond our own to its role in reshaping our understanding of the universe, Andromeda has been a constant source of awe and inspiration. Its spiral arms, teeming with stars and nebulae, remind us of the dynamic beauty of the cosmos, while its inevitable collision with the Milky Way hints at the ever-changing nature of the universe itself. Andromeda's secrets are not just scientific, they are deeply human. Its light, traveling for millions of years to reach us, connects us to a past that predates our very existence. It invites us to ponder our place in the universe, to marvel at the vastness of space, and to dream of what lies beyond. Whether you're an avid stargazer or simply someone who enjoys gazing at the night sky, Andromeda offers a profound reminder of the mysteries that surround us. So, the next time you find yourself under a clear night sky, take a moment to look up. Let your eyes wander toward the faint glow of Andromeda, a galaxy that has inspired generations of explorers, thinkers, and dreamers. Let its light remind you of the infinite possibilities that await, not just in the stars, but within yourself. As we conclude this journey, let the Andromeda Galaxy be your guide to wonder and curiosity. Its story is a testament to the beauty and complexity of the universe, and a gentle reminder that we are all part of something much larger than ourselves. So, as you drift off to sleep tonight, let the stars above carry your thoughts to distant galaxies, where the mysteries of the cosmos continue to unfold. Thank you for joining us on this journey through the secrets of the Andromeda Galaxy. If you enjoyed this exploration, don't forget to like, subscribe, and hit the notification bell for more cosmic adventures. Until next time, keep looking up and let the stars remind you of the infinite possibilities that await. Sweet dreams, and may the wonders of the universe fill your nights with peace and inspiration.